It's your favorite math professor here, Dr. Hubert, and I'm back with another video. This time talking about outliers. You see my nice little image here. We have these individuals over here all grouped together, and then we have this one little individual over here that's separated from those. Yeah, that's a good visual representation of what an outlier is because it stands out from the rest of the pack, all right? That's what we're going to be talking about here. What is an outlier, and how in the world do you know if you have outliers, or how do you find those outliers? So outliers are extreme observations in the data set, all right? An example is if we have a data set, and this is a dot plot, and these are our points for, or these are our data points, yes, for the number of oranges in a bag. You can see the majority of them fall over here. And then we have this one little one out here all by itself alone. This 10 right here will be considered an outlier. This represents the number of oranges in the bag. You have 2 bags with 4, 1, 2, 3, 4, 5, 6 bags with 5 oranges, 4 bags with 6 oranges, and 1, 2, 3, 4, 5, 6, 7 bags with 7 oranges. And then you got 1 bag with 10 oranges. And so this is this will be considered an outlier. It stands out from the rest of the pack. All right. Now, we're going to look at how do you calculate to see if you have outliers in your data set. And here are the steps for doing that. There are 4 steps. Yes, there are 4 steps, but they're not bad, okay? The first step is you want to determine the first and the third quartiles. That's your Q1 and your Q3, which we talked about in the last video, calculating quartiles. And then you want to compute the inner quartile range, which we also talked about in the last video, but that's your Q3 minus your Q1. And then you want to determine your fences. The fences serve as cutoff points for determining outliers, and you determine those by doing your lower fence is equal to Q1 minus 1.5 times your inner quartile range, and your upper fence is equal to Q3 plus 1.5 times your inner quartile range, all right? And then if you have any data values that are less than the lower fence or greater than the upper fence, then those data points are considered an outlier. So let's look at an example to see how this works. Okay, now this is long, so just bear with me here. A credit card company has a fraud detection service that determines if a card has any unusual activity. The company maintains a database of daily charges on a customer's credit card. Days when the card was inactive or are excluded from the database. If a day's worth of charges appear unusual, the customer is contacted to make sure that the credit card has not been compromised. Use the following daily charges rounded to the nearest dollar to determine the amount the daily charges must exceed before the customer is contacted, okay? So these are daily charges for 20 days, 143, 166, and so forth. And so what we want to do is we want to see what are the outliers. Actually, we just want to know what's the upper fence, because it says what's the amount the daily charges must exceed before the customer is contacted. So an outlier would lie above that upper fence. So we need to know what the upper fence is. But we're going to go through and calculate both the upper fence and the lower fence. But just to let you know, this problem only wants to know the upper fence, all right? So first thing we need to do is find if I go back to my steps, we need to find our Q1 and our Q3, and then we need to find our IQR. And then we'll come back and calculate the lower fence and the upper fence. So in order to find our Q1 and our Q3, we have to put our data in order. So we're going to take these 20 numbers and put them in order from smallest to biggest, and I have done that here. I have 20, 46, 68, 70, so going this way. And I've separated them. It was 20 numbers, so I separated it from the lowest 10 and the highest 10. So I have my lowest 10 up here at the top, my highest 10 at the bottom here. So the first thing I want to calculate is our Q1, which is going to be the median of the first half of the data, which I've put the first half at the top here. And remember, there are 10 numbers up here at the top because there were 20 total. You divide that in 2, you got 10 and 10. So you got 10 in the top half and 10 in the bottom half. In order to find the median when there is an even number of numbers, your median is going to be the average of the 2 middle numbers. And those 2 middle numbers are 79 and 89. So for Q1, we want to take the average of 79 and 89. So do 79 plus 89 divided by 2. And 79 plus 89 divided by 2 is going to give us 84. So the median of the upper half of the data is 84. So our Q1 is 84. And we'll do the same thing for Q3, but we're going to do the bottom half. So in the 5th and 6th position is 133 and 143. So we'll take the average of those two numbers to get our Q3. So we'll do 133 plus 143 divided by 2. And when we work that out, we get 138. So our Q3 is 138. That is the median of the bottom half of the numbers. So now recall that the interquartile range is Q3 minus Q1. So that's going to be the 138 minus the 84, which is 54. So our IQR, our interquartile range, is 54. Remember, that is the range of the middle half of the data. So that's the range from the Q1 to the Q3. So now we want to find our lower fence and our upper fence. And if you can recall, the formula for the lower fence is you're going to do Q1 minus not equal. Q1 minus 1.5 times your IQR. And then your upper fence is going to be Q3 plus 1.5 times your IQR. All right, your Q1 is 84. You're going to do minus 1.5 times your IQR, which is 54. And when you work that all out, you do 84. 1.5 times 84, that ends up being 81. So you get 84 minus 81, which is 3. That's your lower fence. And then your Q3 is 138 plus 1.5 times 54. And we just found out that 1.5 times 54 is 81. So you add 138 and 81, and you get 219. So your lower fence is 3, your upper fence is 219. What that means is that if there are any data values that are less than 3, which we can look at our chart up there and tell there are none, that would be considered an outlier. And on the opposite end, if there are any data values bigger than 219, then that would also be considered an outlier. And we can tell in our data values at the top, there are none that are bigger than 219, all right? But it asked us, the question was, what was the upper fence? Basically, it wanted to know what amount did it have to exceed in order to be notified. And so that amount would be 219. So I believe I included an explanation here. Yeah. So the interpretation is the customer will be contacted if the daily charges exceed $219 because that's the upper fence. And so that is how you would determine if there are any outliers by calculating the lower fence and the upper fence and seeing if any data values hit outside of those upper fence values. Alrighty, so this is outliers. If you have any questions regarding outliers, please don't hesitate to put them in the comments or send me an email directly. I do thank you for watching, and I look forward to seeing you again in the next video.